Very good morning to everyone. In this lecture, EC8351, Electronic Circuit 1, Department of Electronics and Communication Engineering. In previous session, we are discussing the various biasing of BJT, like fixed biasing mode and voltage divider biasing mode. So now today we are going to discuss the emitter stabilized bias circuits. So here the emitter stabilized bias circuit, how to implement the circuit, that is to improve the stability of the biasing of circuit over the fixed bias and also the voltage divider bias. The emitter resistance is connected in the biasing circuit. Such biasing circuit is known as emitter biasing circuit. So here the circuit analysis, we are moved to the input side. So we can draw the circuit of BJT bipolar junction transistor model. So first the supply voltage VCC, and also we are connecting the base resistance in the base configuration side, and the emitter resistance is connected to the emitter side, and the collector resistance is connected in the output side. So we focus the circuit analysis first the base circuit, that is the input side. If applying the Kirchhoff's voltage law to base circuit, we get the equation of the supply voltage minus the base voltage into the base resistance minus base emitter voltage minus emitter current and emitter resistance is equal to 0. So we have the emitter current is equal to 1 plus beta into IB. So the IE, that is the emitter current, in the equation we can get the Kirchhoff's voltage law to produce a base current, that is the supply voltage minus IB, that is a base current, into base resistance minus VBE minus 1 plus beta IB IE is equal to 0. So VCC, it can be simplified that the equation, the main supply voltage minus we can take the base emitter voltage is equal for the base current and the base resistance plus 1 plus current amplification factor into the base current and the emitter resistance. So in this equation we have to consolidated the base current. What are the base current? IB is equal to the supply voltage of the main supply voltage, initial supply voltage, and the input voltage VCC minus VBE divided by the resistance into the current amplification factor, that is RB plus 1 plus beta into RE. So next we have to move to the output side, that is a collector circuit. Here the collector circuit, if we applying the Kirchhoff's voltage law to the collector circuit, we have the supply voltage, that is initial voltage plus VCC is connected between the resistance, that is a collector resistance. We are connecting the output side. So the initial voltage we have to start the conduction, that is the threshold voltage of the transistor. So we have to applying the Kirchhoff's voltage law to the output side, we get the equation for the initial supply voltage minus the collector current into the collector resistance minus the collector emitter voltage minus emitter current into emitter resistance is equal to 0. So we can simplify that equation. The collector voltage is equal to VCC plus IC into RC minus IE into RG. Here the VE, we can identify the emitter voltage. So the emitter voltage is nothing but is equivalent to the emitter current and emitter resistance. The same for the collector emitter voltage is equal to collector voltage minus emitter voltage, and then same for the collector voltage is equal to the initial threshold voltage minus the collector current and collector resistance. So the analysis, so we have to facing the analysis of the input and output side, that is a BJT. So BJT is a bipolar junction transistor. It is connected with the three terminal: base, emitter and collector. So in stability factor, so we have to improve the stability factor over the fixed and voltage divider biasing. So we have to connect it in the emitter resistance in the emitter side. So this is a difference between the fixed and voltage divider biasing of to improve the stability factor of emitter stabilizer based circuits. So the analysis we focus the base circuit and also the collector circuit, that is the input and output. We have to improve the input side and also we have to improve the output side. So we have to the output is better than the fixed and voltage divider bias to improve the stability of the current, that is how output current and the input current. So in this lecture we have to study the emitter stabilizer bias circuit of BJT biasing. In upcoming session we are going to discuss the stability factor of BJT configuration. Thank you for watching this video.